All right. Thanks, everyone. Thanks for having me. So today, I want to talk about D3 and kind of in the context of big data, right? That's kind of the group. But first, who here works in big data? Okay, that's a good number of people, like half of you. What about web development? Who here either works in web development as a web developer or at least is familiar with web development technology? So HTML, CSS, and JavaScript, right? Okay, that's good. So that's like half of you. So D3 is about web technologies, right? There's a lot of tools that data scientists use that have nothing to do with the web, right? Analytics, data crunching stuff. That's not really has anything to do with opening up a website in the browser, but D3, that's what it's about. So it's not really a prerequisite for this talk, but if you don't know anything about JavaScript or HTML or CSS, like some of this stuff might not make any sense, and that's okay. But just know that if you decide to kind of embark on the path of learning D3 is partly about learning about web standards. So you'll be learning about how to build websites, basically. So why are we interested in data viz as data scientists? Well, I asked how many of you work in big data, right? But what does that really mean? It's kind of like a buzzword for sure, right? But to me, one of the ideas behind big data is data that's so big, so much that it's incomprehensible to us, right? We can't grasp insights from just a big data set. Literally, we can't conceive of that. Our human capacity is too limited. So one solution that data scientists have come up with for dealing with this problem is data visualization, right? And data visualization basically helps out in two ways. It helps us communicate things that we know about data to other people, and it helps us explore, right? So let's say I have some information I want to tell you, and this is one way to do it, right? This is some information about Apple's earnings or their stock price, right? And I can do this, or I could just show you this, right? And right away you understand what's going on, right? Once you understand what the graph is saying, which is not too difficult, let's say it's a graph of stock price over time, you can look at that, you can see, you can grasp a lot of information in a very short period of time, right? Data visualizations provide us with a dense amount of information. And so they let us get the idea behind big data really quickly. And so that helps us communicate, but visualizations can also help us explore data sets, right? If we think of the data that's behind this visualization as rows in a database, again, like as humans, we can't just look and understand those rows and get insight from them. But here, let's say that this is a graph of stock prices, change in stock price, a daily change. Each one of those squares represents a day, and the darker divisions are months. And so we can see on this axis right here, this is 2005, 2006. So let's say this is the Dow, right? And we just want to explore this data. Let's say we have years of this, and we can just look at this very quickly. And it looks like something happened, maybe towards the end of 2008, maybe October, November-ish, right? So something happened right there, right? And we can see that right away. So this is another way that data viz helps us out, right? It helps us explore. And so this is important for data scientists. So now let's come back to D3. So what is D3? D3 stands for, make this bigger, data-driven documents. What does documents mean here? Well, document actually refers to the DOM. And that's an acronym for the Document Object Model. And this is coming back to web standards. So when you see a web page in the browser, what you're looking at is a document, right? For those of you who don't know anything about web technologies, basically, when you make a request in the browser, a server somewhere is generating up a HTML document, which is just tags. And then it sends it over the wire. Your browser gets it, parses it, and then it understands it, knows how to render the different pieces of that document. And then it can style the different pieces of that document. And that's how we view websites. So the DOM is really a term that is a reference for that living, breathing document, right? The plain HTML that exists, that's generated from the server, it's just string. It's just a text file. And it doesn't do anything for us. the browser can take that and turn that into this living, breathing document. So that's kind of what the DOM is. And the DOM also lets us agree on a standard for how to query this document, right? There's information within this document. There's text, there's pictures, there might be data. And we need an agreed upon set of terms for how to access it, how to manipulate it, how to transform it. So that's really what the DOM is. It's kind of like an abstract concept, but that's what it means. And in D3, which stands for data-driven documents, that's what document refers to. So we're talking about this living, breathing thing that's a representation of a website. And we've been developing tools for web programming for a while now, right? Like the web has gotten so sophisticated and advanced, and people are developing things for it in all sorts of ways. But mostly what people have been doing is building tools for GUI programming, right? Like mostly what we do, besides viewing documents on the web, is we use web apps. And so a lot of the focus for the web technologies lately has been on building better web apps and tools for building web apps easier, faster, more reliably, more safely, right? But if we think back to these visualizations that we just saw, that's not really a web application in the sense of logging into a site and creating a to-do list or something like that, right? It's a different kind of thing. So the reason we have D3 is because the tools that we have for the web that are largely being developed for almost every other application, they're not really well suited to do this kind of thing, right? We need a new vocabulary for creating data visualizations in a way that's easy, right? And that's where the DOM comes in, because the DOM gives us the standards with which to access, query, transform. And now D3 is giving us a language to do that. It's giving us a very natural way to do that in a sense, in a way that makes sense for creating visualizations. So that's kind of the idea behind D3. And it's data-driven because ultimately what we're doing is we're creating and transforming documents in a data-driven way. We're not manually doing this. We're doing it with some data set. So that's the idea behind D3. So let's say we have some hypothetical bars in our document, right? We want to set their heights. Now, with plain JavaScript, now, again, just to make sure everyone's on the same page, it's okay if you don't know JavaScript, but for those of you who don't know anything about the web, JavaScript is a programming language that's executed in the browser, right? So in any website, you can just pop this open, and there's JavaScript that could be part of the DOM, which is the parsed document that lives in your browser, and you can actually pull up this console and start writing JavaScript, right? And so JavaScript is the language that D3 operates on. It's the language of the browser. It's the programming language of the web. So if we wanted to set heights of a bar chart, let's say we're making a bar chart, a data visualization, and we want to do it with just plain JavaScript. So here we have this array of data, and we create this local variable bars. And this is part of the DOM's access. We call document.getElements by tag name, rect. That's the way that we select rectangles out of the DOM. And then we do this kind of iteration. We use a for loop, and for each bar we set the height according to some piece of data. We grab the ith element of the data array and then set the height of that bar accordingly. So this is how we can do it in JavaScript, right? And it's pretty verbose. With D3, we get some easier methods. D3, we're going to get into this later, but D3 is this global object. It gives us a select all method, so it's an easier way to do what we just did. And then we can actually set the height of all those bars just like this. Now, this is kind of a glimpse into the power of D3. Notice we're not iterating over explicitly each of the bars in the collection, right? We're just setting the height on the entire collection. And we're setting it with a function. So this function is taking in two parameters, d and I. D represents a data point. So for example, one of the elements in that array. And I represents the index. So in D3, again, we're transforming documents in a data-driven way. This function is smart. It knows about our objects that we want to act on. It knows what data they represent. It knows what index they're in. And in that way, we can easily create these visualizations. It's particularly well suited for this kind of thing versus the code at the top where we have to think about every single step.
Was it replacing the D3? Was it replacing the top section?
it's replacing everything but the data. So right there, all of that. So in the top section, plain JavaScript, we want to change each of the bars. We have to go through a loop. We use a loop. Now implicitly, D3 is doing the same thing, but that's kind of the point. D3 is giving us this vocabulary for changing these things in a way that we intend. We just write what our intention is, and it takes care of it for us. And it's going to open the door for a lot more powerful things. We'll see. So D3, really quick before we actually get into it, I just want to cover what it's not. It's not just about querying the DOM. So for those of you who are web developers or familiar with JavaScript, jQuery is a library that's extremely popular, and it's useful for querying the DOM and doing some transformations on it. And it's mostly about taking care of cross-browser inconsistencies. That's not what D3 is for. D3 is not a compatibility layer. D3, interestingly, is also not a charting library. There's no D3.barchart that you can just create out of the box, right? People make those things with D3 because D3 is good for that, but out of the box, it doesn't come with any pre-canned data visualizations. It's also not easy. To this day, I've never encountered anyone who says D3 is easy. Now, I'm not brilliant or anything, and I know a decent amount about it, so you can learn it. It just takes longer. And it's kind of a different style of programming than a lot of things. So there's a lot of just fighting with the code examples and trying to wrap your head around them. And hopefully some of the stuff I say today will move you along that path a little faster. It's also, again, not proprietary third-party technology. Like the graphs that we saw, they're not Flash scripts that are embedded in the page or Java applets, right? It's web standards. It's the native pieces that the browser knows how to render. That's the same thing we're talking about here. Those are the same pieces that D3 is manipulating. So how can D3 help us? Well, basically, there's a lot of libraries out there that can do a lot of things we want. When we go to D3, it's because we want more power. I kind of think of it like a stick-shift car, right? When you drive a stick-shift car, what's the trade-off you're making? It's definitely less convenient. You don't have an extra hand to hold coffee or read text messages, which none of you do anyways. But you get more power, right? You get more control over the car. So it's the same idea here. D3 is very low level. It's going to be less convenient than a lot of solutions, but it's going to give us a lot more power. So the path to learn. Examples. The community just shines with examples. The main author is very involved with the community. It was part of his work as his PhD thesis at Stanford, and now he spends a lot of his time keeping up with the community and providing tools for people to share examples, and he'll answer questions on Stack Overflow with examples, and it creates for a very warm environment among the community that has all sorts of examples. And so that's really the first place people start, right? You go to the main web page, and this is what it looks like. So it explains it right here, but above the fold, the first thing you see are these things. You can click right here, and it's going to show you something. And right here, this is the code that we're seeing executed right now. So this is, and remember, this is not the DOM, right? This is the flat code, but the browser is running it. And so this is kind of like the DOM. This is kind of like what gets parsed and understood. The scripts get executed, and this is the result. So this fact that the home page has this is an extremely powerful tool for learning. And there's so many cool things here. Some of these go to the New York Times, which is where the author of the framework now works, and he does these sort of things. You might have seen these. This is all D3, and this is all, a lot of it is his work. So when learning, a lot of it is about looking at these examples. Practice. Practicing JavaScript is super easy because you don't have to have Apache running to parse your JavaScript. You don't have to have certain tools installed on your server to compile it, right? You literally, just like I showed you at the beginning, you can pop open the inspector in the browser and start writing. So it makes it extremely easy to practice. There's a lot of good reading on it, and then you just kind of repeat. So today, instead of showing you maybe one of these things and then going through step by step and walking you through the pieces, I don't feel like that's actually that useful when you're starting out D3. Again, because you can do that yourself. All the steps are right there on the page. There's no point in me doing that. What I'm going to do is just focus on a few of the core higher level aspects of the library that are really fundamental to every visualization. It's really the backbone of the library, and hopefully just help you wrap your head around it a little bit more. It's just these topics are those kinds of things where you have to see them explained in several ways before you really get it. So that's kind of what we're going to focus on today. Okay, so this is what we're building. Not nearly as cool as some of the stuff on the examples page. It's a bar chart, right? But I'm going to use it to explain some of the concepts. So this is going to be our sandbox. This I was working on the MIT logo right before we came. So here I have, this is my text editor, and this is just a file, and it's just a plain text file that I've saved on my machine, and you can just open it in a browser, and here we see the same code. Right? This is the code, and this is the DOM. Now you'll notice it's different. Again, it's different. There's a head tag here. The browser automatically put that in. I don't have a head tag in my HTML document. Right? So just another reason why HTML is not the same thing as the DOM. DOM is like this living, breathing thing that actually exists. So this is all we need to get started. So let's build that bar chart, right? We have some data. It's just an array of these 6 data points, and it's just as simple as any other programming language. We store that in this variable. Let's reload the page, the right page, and we can actually pull up this console and see nums. So there's the data, right? Now to build these bars, we actually need an SVG element as a container. So we're going to do that next. What does that look like? Here's the code. d3.selectBody.append SVG. So here, D3 is the global object. If you notice in our code, up here, the first thing we do is we just reference a copy of the D3 library. And that basically, once the browser executes that, it gives us access to this global variable, D3. And this is how we use the library. And it gives us some methods, one of which is select. This is letting us select elements that exist in the DOM, right? So we're selecting the body element. And then we're appending a new element, the SVG element. So if we just run this in the code, so here we just see in our DOM right now is our body element and 2 script tags. This is D3. Here's the script that is in our text editor. There's no other tags. D3.selectBody. We can see right here in the inspector, it shows us we've selected the body. And if we append, can everyone see that? That's a little low. Let me do. Oh no, you can guys see it. And then if we append the SVG element, now we look in our DOM. There it is. There's an SVG element, right? So that's kind of how we can append items we can add to the DOM as we execute JavaScript. So again, for those of you familiar with jQuery, D3 is similar to the $sign. And it lets us select elements just like jQuery. And we can perform operations on them. Append, we just saw, we append an element to the DOM. We can style things, so we can D3.select the body. And now we have that selection again. We have hold of it, and we can style. We can set the style of the background color to blue, right? Again, the living, breathing DOM is changing as we program it. That's kind of the very first level, basics, right? When we called append and we added the SVG element to the DOM, that actually returned a new selection. So when we call d3.selectBody, it seems like we're just doing that so that we can operate on it. But there's actually a lot going on in that function. That function returns this object we can see right here. And it points to the body, this element that exists in the DOM. But it does a lot more. So the first step to thinking about selections, which is one of the core primitives of D3, is to think of it as higher level than the actual elements that you're selecting. So that's something I'm going to say several times tonight, but it's really important. It seems simple. It's just something you have to wrap your head around. Selections in D3 are higher level than the actual elements in the DOM, which they reference. Right? They're two different things. They represent elements in the DOM, but they represent more than that. So when we call append, so first we select the body. We have a D3 selection that refers to the body. We call append SVG, and we get a new SVG element. And what that returns is actually a new selection that refers to that SVG element. And so a lot of times in D3 code, you'll see code like this, where we store that return selection in this local variable SVG, right? And so if we refresh and do it again, we can see D3.selectBody. Here's the D3 selection, and there's the body. If we call D3.selectAppend SVG, here's the return value of that operation, which is the SVG element, right? And so we could select it and work with it, or we could just store it in this variable, and now we can work with this variable just as if we had called D3.selectSVG. It's the same thing. So we're making this bar chart. We have the parent container for the SVG element. Now we want to make the bars. So one thing we could do, remember we have 6 elements of data. We could just append 6 rectangles, right? We have SVG. We could just call append rect. We do it once. We can look in our SVG right here, and we see there's the element. So we could just call that 6 more times, right? One too many. Delete that one. So here's 6 elements. So that's working just like we would expect. But obviously this falls short, right? This is not how we want to do it. We want to do things dynamically. Before we get there, we want to dive a little bit deeper into selections. So far we've seen the main select method. It selects one element, gives us an object that refers to one thing in the document. But there's this other method called select all, and it wraps arrays of elements, right? So we can go to a site and get all of the paragraphs. Let's go to the D3 site, open up the inspector. We see lots of paragraphs of text here, right? D3.selectAll P. So it looks like there's 32 paragraphs of text right on this document. Now we have a selection that represents all those things. We can do anything we want with them. Background color green. Right, so it's the same idea. Remember, D3 is not just about SVG. It's not even really just about data visualization. It's about working with the DOM in a data-driven way. So we're changing the background color of paragraphs, which is something you probably wouldn't use D3 for typically, but you can, and you can do a lot of cool stuff with D3. It's really about these low-level rules, tools, give us a good API for working with the DOM. But here we've selected all the paragraphs with one method. So select all wraps an array of paragraphs. But again, the selection, it returns a single selection, right? It doesn't return 32 different selections, each of which wraps one paragraph. It's returning us one selection, and it references all 32 paragraphs. So again, selections, you want to kind of think of them as a managing object. They manage things. And they can refer to different elements that exist in the DOM, but they're higher level than that. So it knows more than what's just about in a DOM. Some cool things that selections let us do, they let us write declaratively. So this is an example of imperative code. Think about the beginning when we wanted to set the heights of the bars, right? We had to think through the steps. What would that take? Well, we should go through each bar in the collection and set its height individually. That's imperative programming because we're thinking about how to actually accomplish the task that we want to do. If we wanted to set the background color like I did imperatively, we might think of something like this, paragraphs.for each, and then for each paragraph we can set its background color. But with selections, because they're this higher level thing, they're this managing object, and they know about all the paragraphs, we can write code declaratively. What do we want to do? We want to set the background color of all the paragraphs. So we have a selection that represents all the paragraphs, and we just set the background color to green, right? Of course, under the hood, it's using loops and all the native JavaScript stuff, but as you can already tell, it's a very powerful abstraction, and it lets us do things that we literally just wouldn't be able to wrap our minds around if we had to think through the steps of every operation we wanted to perform. So this is something that's very powerful about selections. So at this point, actually, I want to pause and ask, does anyone have any questions about what I'm saying?
This is regular JavaScript, not D3.
The top is more like pseudocode. I think some browsers do have for each, and I think it's. I'm not sure about the compatibility, but yes, this is regular JavaScript, right? It might be a little more verbose, setting CSS styles with regular JavaScript. Everyone uses jQuery for this kind of stuff these days a lot of times, but this is the idea. Even if you're using jQuery, a lot of times you're doing things imperatively, right? But with data viz, a lot of times, and in D3 in particular, we write code declaratively. So, yeah. Was the browser support for D3? D3 is made to work with modern browsers. That's what the author says. There's a couple of libraries which will give shim support for some of the elements that the older browsers don't support, but it's not going to work on, I don't think it works on IE8. I'm not sure, can anyone else speak to that? Modern browsers, basically. Yeah.
Earlier you did a select all and then passed a function, and the function had arguments D and I. Where did the D and I come from?
We'll get to that later. So he asked, where did the D and I come from the function that we passed earlier to the select all? We're going to get to that in just a minute. But I want to make sure we all understand this first. Okay? Yeah? Yep. So the question was, when we select all, so far we've just been selecting the elements, right? The actual elements, the tags, based on the tags. But for those of you who don't know about web standards, the DOM in HTML, it's not just tags, it's also classes. So you can see right here, this is a div tag with a class of column, and again, the DOM, which provides us a agreed upon set of terms for accessing, for querying the DOM, the way we refer to a class is with a period. There's a string that lets us query the DOM. So far we've just been using terms like bar, or rect rather, but we can also select by classes, for example, dot column. Dot represents a column. So if we do d3 dot select all column, that gives us this array of two elements. So apparently there's two divs in here. So, and it's a much richer than just that. You can do descendant selections. There's all sorts of things. So this is part of the power also. This is, again, why D3 is about web standards. It's leveraging this API that people know about, how to query the DOM, and it builds on top of that. So yeah. Okay, so let's move on. So now we come to an interesting point. Selections. We can actually select no elements. Say we just have an empty SVG element in our document, and now we create this local variable bars and we select all the recs. Well, that's kind of weird. Why would we do that? Here we have d3.select the body, append an SVG element. It's empty, right? Equals d3.select all rectangles. So bars, it's something. It looks like it's an array of an empty array. It doesn't refer to anything in the DOM, right? But it still exists. If we just were to select things that don't exist in jQuery, that's kind of useless, right? If we wanted to change something that doesn't exist, we just get like an empty set or undefined or null or something that means basically nothing, right? Nothing we can really do with it. If we were to apply a CSS rule to elements that don't exist in the DOM, that's useless, right? It doesn't do anything for us. But actually, with D3, this is really important. So again, selections are higher level than the elements that currently exist in the DOM. You can select things that don't exist, but you still have something that is important. So in this case, bars doesn't refer to anything that's in the DOM, but it does represent an array of rectangle elements because we've called select all. So selections really have two pieces, right? The current DOM portion, which is what we've talked about so far. Things are in the DOM, D3 lets us select those. And that's kind of one thing that it knows about. But they also have this more abstract thing, this representation, right? d3.select all rect. That's like a representation of an array of rectangles. It's kind of like a platonic thing. It's very abstract, right? But the selection knows about that. d3.select h1. That represents a single h1 tag. It may not exist in the DOM, but the selection knows about it. So as you can imagine, knowing both pieces is going to be really important for D3 because it's going to let D3 compare the two sets, right? And this is kind of the key to its power. And this brings us to the data join, which goes back to the original code that I showed you. So when we select things in the DOM, we're selecting something tangible, right? Say we have those 6 bars, and let's say they look like this, right? These things have all sorts of attributes about them. They have X and Y, they have widths and heights. They're tangible, they're real. We select all rect, and we get an array of 6 rect elements with all their attributes. But I just told you that when we just do bars, select all rect, and there's nothing there, it still represents an array of rectangles, right? But it doesn't represent much more than that. That's very general and abstract. That's not very useful, right? The array is, how long is the array? Like, what are the numbers in the array or objects in the array that this selection represents? It's just very arbitrary and generic. So we need a richer way to describe the representation, right? We need a better way to describe what this selection represents, apart from what currently exists in the DOM. And this is where data joins come in. So here we have our original array of numbers. It's a 6-element array. And we call bars svg.selectAllRect .data. This is the data join. And then we pass in our array, nums, right? And so now, let's do this. d3.select body append svg. Now this returns the svg element, so we can just work right off of this. We want to select all the rectangle elements. This, again, is like this arbitrary platonic representation of an array of recs, but we want to give it something specific. And we have this nums property already. Now we have something tangible. Nothing exists in the DOM yet. The SVG element is still empty, right? But this selection that we have has a length of 6, right? So it knows about that data. And that's kind of the way that we can create these richer representations. So our representation is now explicit. So to make the picture complete, selections have 2 portions. With data joins, we have a way to richly describe what they represent. And with querying the DOM, we have a way to get exactly what currently exists in the DOM, right? And now we can overlap these 2, and this yields 3 sub-selections, what they're called in D3, named enter, update, and exit. The circle on the left represents the representation, basically the data join we just did. So in that case, we have 6 recs, which correspond to those numbers in that array. They don't exist in the DOM, but that's them. So if they don't exist in the DOM and they do exist in that data join, they're part of the enter subselection, right? And why is it called enter? Well, typically, if you have something that's in your data set but not in the DOM, you're going to want to append it like we've been doing, right? So that's why it's called enter. If you're familiar with web development, one way to think about this, an analogy, is if you're building like a JavaScript application, you have your actual data on the server, like the truth data, right? That's like your source of truth, what's living in a database somewhere. And then you have the client state. You have the data that currently exists in the application on the client side of your application. And those things come out of sync, right? That's one of the hardest parts about building a GUI, is keeping the client's interface in sync with the data that's in the databases on the server. And so you can think of the same overlap, right? You have data that exists in the server, not in the client. Data that exists in the client, not in the server, and then the overlap. Data that exists on the server, not in the client, you need to draw that. You need to render it for the user, right? And similarly, data that's no longer relevant, you need to get rid of that. That's the exit subselection. And then update subselection doesn't really make sense in the context of a flat array like we're talking about, but you can imagine typically the arrays won't just be arrays of integers, they'll be arrays of objects, let's say, people objects that have first and last names. And even though the first and last name won't change, some other detail about them will change. Like the newest item in their news feed, right? So that would be the update selection. That's data on the server that should still exist on the client, but some piece of it needs to be updated. Right? Or in the case of data visualization, maybe we have stock price, and this particular stock still exists, the Apple stock we're looking at, but there's some new piece of data for it. So this is kind of coming full circle to everything there is about selections. And so how does this look in practice, right? This is literally what D3 is doing for us, giving us this way to describe representations, query the DOM, and then it gives us access to these 3 sub-selections. So what does it look like to actually work with this? Well, we can just call .enter on that selection, and that returns that sub-selection. And then we can do with those elements whatever we want. So that's how we get the bars in here in a data-driven way, right? Let's get the SVG element. There it is. And let's select all the rectangles, which don't exist. Let's bind the data. This gives us a selection, right? Now, we want to get at the ones that don't exist in the DOM yet, so we can append them. And the way we do that is just with enter. With those 6, we want to actually just append a rectangle element. And so now we see our SVG has 6 rectangles, right? So this is kind of coming full circle. This is the data-driven way to do this. Our selection is now smarter about what it needs to do.
Why is it called enter?
So it's called enter because typically, not always, not necessarily so, but typically what you want to do with new data is append it to the DOM. You want to create those elements. Think of a scatter plot where you have lots of dots that represent two on a coordinate system, some piece of data. And a new coordinate comes. You want to plot it, right? Like if there's a new piece of data, you want to plot it. If there's a new entry for what the stock price is as of the last minute, you want to put it there. So it's called enter. It's kind of like a convention almost, because typically what you're going to do is append them. Now you don't have to do that. And similarly with exit, you don't have to remove those elements either. You can do whatever you want with them. You can keep them in the DOM and just transition them away, or fade them to 10% opacity, or make them gray, right? And again, that's why D3 is lower level than any specific visualization. It's just giving us tools to work with data-driven documents, right? This is what's interesting when we're working with data that's changing. What's new, what's old, what's the same, what's updating. And D3 gives us an extremely simple way to work with it. Does that answer your question? Okay. So now, finally, where does the data actually live? We can actually come here and let's not worry about the existing variables we have. Let's just come as if we came to this document fresh. And let's select all the rectangles. There they are. And we knew we could do that before, right? But if we call .data, we get the array back, right? So the data actually lives in the DOM. And if we look at the inspection, if we inspect this selection, here's the first rectangle. We can't see it right now. In the top left, you can see the arrow pointing to it. It's where it's being rendered, but we can't see it because there's no width to it and there's no height to it, right? So it's not producing anything visual, but it is part of the live DOM and it is being rendered to the screen. And the inspector shows data underscore, and that holds the 80, which is the first element in our array. There's a second one, 53, right? So when we appended those, it really is binding the data to those elements, right? It's putting them in the document and actually adding the data as properties on the elements. And so this leads to kind of the last main point about selections. Selections are transient, right? The data doesn't live in memory in JavaScript. I mean, it can if you have a variable that references it, but that's not the point. The point is not that we're adding JavaScript, a layer of JavaScript, and it has some rich object graph that stores our data, which represents something in the server, and then that's what we use, right? No, it lives in the DOM, and it's attached to these elements. And so that means we can discard selections, we can create new selections, we can reselect things and change their data. And so when you are looking at the examples in D3, you're going to come across this a lot of times. And this is exactly why, because the data lives in the DOM. It enables you to do this. Right? So this is kind of the wrapping up. Let's finish our bar chart. So how do we do this? Well, let's just think about it. We have our bars, and we have the rectangles here in the DOM, right? But let's just see what we're working with. First, we want to set their width equal to 20 and their height equal to 20. Okay, so now we're seeing something. It's kind of pathetic, but it's there. It doesn't look like this. I think I just closed it. Let me just get the baked solution here. Right, so here's same thing. Here's the bars that exist, but D3 select all rect, and we see the data is there, right? It's in the DOM. Let's do the width and height again, and I won't close it this time. So they're there. But what's going on? Why do we see like one square? Well, it's because each rectangle we see here in the DOM has a width and height of 20, but they're all right on top of each other. So the rect SVG element has certain properties that are defined for it. One is width, one is height, one is x, and one is y. And x and y are the x and y offsets on the Cartesian plane. So again, part of learning D3 is learning what the spec says about the different SVG elements. So we could let's just set the x to something like 20, right? And so we're moving it around now, but we're still moving them all together. When we think about the bar chart, we want to move them separately, right? We want to make them apart. And how far we move them is based on which index that each bar is in the collection. And so this is going to be an example of a data-driven transformation. So far, we've been setting these attributes to static numbers, right? Width 20, background color green. But instead of a static number, we can actually add a function right here. And this function, the second parameter of .adder, .style, a couple other methods in D3, it accepts two parameters. One is, and we just call these by convention, D and I. D represents the data that is bound to that element, and I represents the index, right? But again, like this is one of the weird things. We're not looping through each one and checking for it. We're acting on the entire collection as a whole. This is going back to the declarative style that we write D3 in. So you want to think when you write this function, each time you're going to be working with the correct data point for that bar, or the correct index. In this case, we want to move things over farther if they're farther along. So let's just move things over by 30 pixels times the index, right? Okay, so now we're getting somewhere. And we can actually see in the DOM here, x is 0 for this one because 30 times 0 is the first element. It's a 0-based index, is 0, 30, 60, 90, so just what we'd expect. Okay, now we have the data in the array, so what do we really want to do is we want to set the height based on the data in the array, right? So let's do that. We're going to set the height, and we'll just return, instead of I, we'll just return D. And D gives us that shape that we expect. Except this is not looking like a bar chart, right? This is kind of looking weird. What's happening is SVG renders starting in the top left. 0, 0 is up here. And so we're moving over, and then for a positive y value or a positive height, we move down. And so what's the fix to this? Well, you can think we could just translate it, right? If we have the total height is, say, what's the max value on our data? It's 200. So this is 200 right here. And if we just moved them down, offset them, we left the height is correct, right? But they're not lined up accordingly. So if we just offset them by the height minus the value, it should work, right? Bars dot adder y. We want to do this in a data-driven way, right? The offset is different for each bar. We only need the data point. We'll return 200 minus the data point. Right? Okay, that's what we want. So there's our bar chart. All right, cool. We know how to make a bar chart now. So this is like, at this point, you should be able to, I mean, there's all sorts of examples, and there's so much to D3 we haven't even scratched the surface of. There's transitions, which we see here in this really cool chart. We see an axis here, right? There's an axis down there. We see different categories. We see different colors. What we just dealt with, we switched we inverted it, right, to take care of the SVG fact that it renders in the top left. We're really using a scale, if you think about it. We're inverting it. And also, we're just rendering the number of pixels equal to the data in our integer, in our actual array. But if you're wanting to plot, something that represents millions of dollars, you don't want to just draw millions of pixels on the screen. So there's things like scales in D3 that help you do this, right? You set the domain of the scale, you set the range, and it does a transformation for you. There's things like axes that help you do time and value on the different axes. There's events, which is how that last visualization I just showed you does the transitions and responds to button clicks or hovers or all the native DOM events. And then there's transitions, but transitions are really just another form of selection. Really behind all this is selections and data joins. That's kind of the big idea here, and that's why I wanted to spend so much time on it. You can come in here and look at this code. Now it's still going to kind of look like Chinese unless you speak Chinese. But there's all sorts of stuff going on here. We have layouts and stacks. But when you get to the actual code, the actual D3, look, this is just what we did. We're appending. We're setting attributes. We're appending group. G is a group element. It's just used for organizing. We apply data. We work with the enter selection. We work with the exit selection. We work with the update selection. So selections and data joins are the big concept in D3. And again, when you want to learn, you can start off with the gallery, which is what I showed you. It's right off the main homepage. There's tons of examples. There's tutorials, a lot of them written by the author, and I would highly recommend checking out anything that guy writes because he is brilliant and he's a great teacher, and he spends a lot of time on this stuff. So his content is just top-notch. Stack Overflow is really good for questions and answers, and then the D3 mailing list is actually pretty active too on the Google group. And then there's an IRC channel too, and people, you can just pop in there and ask questions, and you usually get a response pretty quick. Practice, use the inspector, look at examples. Finally, I just want to close with a few thoughts on big data. It seems pretty low level, right? Like when we think about big data, what do we think about? Like my company stores 1 billion data points a day, and we run analytics all night, and we have hundreds of metrics that update in real time. How can something so low level be useful? Well, here's a couple examples. Cross filter, this is a library in D3 used at Square. Square is like a mobile payment process, not just mobile payment, but payment processing. It does lots of stuff. But they're extremely big company, and talk about big data. They have tons of data that they work with. They built this library on top of D3, and this particular example has 250,000 data points in the browser, and it lets you actually do real-time filtering. So we see coordinated visualizations here, views. We can set these different things, change the parameters, and all the pieces update, right? So, and it's doing this pretty quick given there's 250,000 observations right here. Great for exploring, great for communicating, like we were talking about earlier. Cubism, this is also made by Square. This example is metrics, but if you watch it, every couple of seconds it updates in real time. The data will move over to the left. This is a cool visualization, these particular charts. Think of these as area charts that are condensed. So instead of a chart just going up or down, you could cut that in half, and it would become darker if it would have gone up, but now you have half the volume. So you can just really quickly see the darker areas represent the higher portions of the graph. It's a way to get even more density out of the visualization, see more what's going on without having to taking up so much space, right? So again, Square uses it for this. These are just a couple of things that I've come across recently. Like Netflix is hiring for a D3 developer to work with Ember because they need a whole new thing to analyze what their traffic loads are like. This is a geo projection. This is something you can do with D3, and it looks like it's mapping some sort of activity based on location, right? Here's some more metrics that are happening. Square Analytics has done something similar. Again, they have the tools that we just showed, but they have this dashboard they provide their retailers to look, to explore the data that they have. Adapar is a financial company. They're pretty big in the open source community, and they've done a lot of cool D3 work. They use it for their platform. There's open source tools that bind D3 to R and Python output. There's a lot of stuff, but at the end of the day, when we think about big data, there's kind of like two layers, right? At the one layer, there is this thing where we have a billion data points a day sitting in a database somewhere, and we can use algorithms, we can use machine learning to investigate it and to aggregate it, right? To clean it, to filter it, and to sort it, and to select it. Clearly, D3 is not a good tool for this kind of thing, and this is something you still have to do when you have a large amount of data that you need to get some insight out of. What D3 is really good at is kind of what we've been looking at tonight. If we have a select, focused data set, and maybe we know something about it, maybe we don't, D3 is giving us a new vocabulary for interacting with it, right? It's kind of like these days, more and more, big data and analytics is about introducing like the human component. And what I mean by that is instead of just taking data, running it through an equation, and then like seeing what the results are, maybe running some tweaks and then hoping for the right answer, right? You have to have this more subtle layer of involvement where you can interact with it dynamically, and you can use your intuition or your instincts to see what is important, what's not, right? And so it's becoming more important for us to be able to develop tools that let us do this, right? And that's kind of where D3 fits into big data. It's giving us a vocabulary, a library to help us create tools to explore data dynamically in real time, right? It's in the web, so it hooks up to things like WebSockets and can update real-time visualizations. So this is kind of key to how D3 fits in, and I think it's going to be more and more important as we move forward into a world that's just replete with data, and we try to wrap our heads around it. So that's all I have time for in my presentation. Thanks. Questions? Yeah.
So I think you started to get this in the last slide, but in your opinion, would you view D3 as more of a complementary tool for something like R or pre-existing Python libraries as opposed to replacement for it?
Yeah, definitely. D3 is about working within the browser, right? So necessarily, like Python or R, output is it could come to the browser in the form of like an image maybe, but you're not going to really be able to interact with it. JavaScript is the language of the browser, and it's what is responsible for all the rich interactivity that we see in web applications today in the data viz world. So if you want to interact with that data, if you want something that's real time, right, D3 is going to do that, but D3 does need its data, so it has to get it from somewhere. So using something like Python or R or any other tool to generate the data, getting it up to the browser is still going to be an important step. Yep.
Something like that cross filter.
Yep.
You know, are all those data coming into the browser to the 50,000 points, or is something being processed on the server?
So in that case, yeah, well, both, right? It's being processed on the server, so either retrieved from a database, and then it's sent up the wire along with the HTML and JavaScript and CSS, and then D3. So you can actually look at an example. D3. So D3 can make a request to the JSON. In this case, it was a JSON file. They make the request, and then once it gets it, it can unpack it and then work with the data. So that's what's happening there, and you can actually see.
It wasn't starting off with 250,000. It was some kind of taking queries real fast.
No. In this case, it's one blob of data, and it starts off with it. But often in these visualizations, there's a WebSocket open to some back end somewhere that's pumping it data, and the visualization will update as a result. You can actually see when you open this inspector, you click network, you refresh, you can see all the requests that are being made, right? Here's the HTML file, here's the CSS, which is styling, there's an image, and we see right here, 3 million flights.json. That's the data. There it is. That's the data right there. Right? So in JavaScript, you can make that request, get it, and then plug it in, and then work with it as just plain arrays. So that's what's happening there. Any other questions?
Just out of curiosity, how big is that JSON file?
5.3 megs. Maybe 1.6 like condensed or gzipped or whatever the condensing is. So 5 megs right there.
Compared to an image,
Yeah,
big deal.
yeah. And D3 can work with a lot more. You know, I'll post my slides and you can follow up with some of those examples. The company's talking about how they work with all the data. I mean, it's pretty impressive what you can do. Obviously, JavaScript's not as fast as libraries that are made for, you know, crunching through gigabytes of data, but it's kind of funny because it turns out not to be as big of a problem because what you're using D3 for, again, is not just crunching through all this stuff. You have to be more selective because there's the human component where you have to interface with the data, and it's important. Part of making good data visualizations, there's kind of an art to it where you decide what to show, how much to show the user, and so it turns out even for some of the best visualizations, you're not going to have a huge worry with that. Yeah. Sorry, what was that? Other methods like update and exit? So enter, exit, and update are kind of like the 3 main methods. There are 3, yes. So we only looked at the enter one, right? Because we just wanted to make that bar chart. But you can imagine if we already had the bar chart on the screen and we send new data, we could rebind the data and then we could maybe do the transitions, kind of like we saw in that one, where now the height is 4 instead of 8. And so the bar would transition down. In that case, the bar already exists in the DOM. So to access that changing element, we would work with the update selection. The way you do that is actually, you don't call .update. With exit, you call .exit. With enter, you call .enter. With update, you actually just work with what you have. As soon as you data bind, you're working with the update selection, because most of the time that's what you do. That's kind of a little thing, but you'll learn this as you look at the examples. The main point is hopefully you have a better understanding of what a selection is now, because that's kind of the D3 primitive that you work with most of the time. But yes, you work with, when you're making these things, you're working with all 3 selections all the time.
So in the enter example you gave, you need to select all of rect, and .data.enter, and then append of rect.
Right.
Is there any reason, could you actually do an append of circle or a selective circle and append of rect? Is there any reason they have to match?
No, they don't. So he's saying we select all the rectangles. They don't exist in the DOM. So we have a selection that kind of represents an array of rectangles. And then we bind data to it. And so there's this enter selection, this enter subselection now. And then we choose what we want to do with that. Because the representation is not tied to anything in the DOM. They're 2 separate things. The selection knows about both of them, but they're 2 separate things. So in that case, we could actually append circles, right? If we were to go reselect rectangles, bind the same data again, now again we would have an enter subselection, right? We wouldn't have, like if we had appended rectangles and then we go and re-query the DOM, now we would have an update selection, right? Or we wouldn't have anything in the enter selection. But it's always about what's different between, so at the moment when you make the selection, the state of the DOM, and then your data binding. So you can do whatever you want with the selections.
Seems like for the update and the exit, you do want to select the thing, but for the enter, it seems like they don't even have to match.
Right. And there's something called nested selections, which is a really important concept. It's difficult. It's kind of complex, but it's how a lot of this stuff works. Like in this case of this grouped bar example, which I've lost. I can't find it, but there's actually nested selections where the top level selection is the groups, and then within each one you have another nested selection, which is each of the individual bars. And so in that case, you are actually working with, first you're selecting something like a group, and then you're appending bars, right? And then you can tell whether the groups change. So you do kind of work like that sometimes. Yep. Yeah. Yeah. Her question was, like, if you're using an existing charting library like Google Charts or something, there's a lot of times there's something you want to do but you can't do it. It's just not part of the API they designed. Are there any limitations like that in D3? Well, no. D3 is working with the DOM directly. So anything that's available in the native SVG elements, you can change with D3. So yeah, basically, what's that? Can you make it responsive? Yeah, you can. It takes some work. But again, it's very low level. So in that case, you would be listening to window resize events. If you hit a certain breakpoint with width, you could call some function in D3 that updates your visualization. So you can basically anything you want to do, right? Just by looking at the examples, you can see, I mean, there's a ton of stuff that you can do. So yeah, I encourage you guys to check these examples out, hopefully get inspired and take a deeper dive. So thanks a lot for your time.